Welcome to section 4.2. This is where we're going to apply congruence in triangles. The big idea for today's lesson is what are congruent figures? So what we're going to do during this section is we're going to learn how to write congruent statements from diagrams. We're going to identify different parts of triangles which are congruent. We're going to use congruence to determine missing measures. And then we're going to apply the third angle theorem to find another pair of angles. Finally, we're going to conclude where we prove when triangles are congruent. So first, let's take a look at what congruent figures actually are. To the left, you'll see three triangles which are congruent. On the right, three triangles which would not be considered congruent. So take a minute to see what the similarities and differences are between these sets of triangles. So what exactly does it take for triangles to be congruent? Well, those triangles should have the same size and shape. For triangles that are not congruent, they're going to have different sizes or shapes. It just takes one different side length or one different angle measure, and the triangles can no longer be considered congruent. All right, so now we're going to talk about when we have congruent figures, what we're actually seeing. In two congruent figures, all the parts of one figure are congruent to the corresponding parts of the other figure. In triangles, that means all of the angles in one triangle are congruent to all of the angles in the other triangle that correspond in the same positions. The same thing with the sides. Congruent statement, so which of the corresponding sides or corresponding angles are congruent between these two figures. Now, what you see down here are different congruent statements. Okay, so we have this one right up here at the top, which is telling us that triangle ABC is congruent to triangle FED. So if we look over at the diagram, we know that those two triangles have 6 sets of corresponding parts. They have 3 sets of angles, which are listed right here, and 3 sets of sides, listed here. Now the nice part about our congruent statement is that the order of the letters actually shows us which parts are congruent. So for example, notice how letter A and letter F showed up first in both of the names for these triangles. Since they're congruent, that means that those two vertices correspond to each other in the triangles. So that's why angle A is congruent to angle F. Now B and E also show up in the second position in both of these statements. So we can see right below, angle B is congruent to angle E because those two vertices correspond to each other. Finally, we have C and D in the third position of both statements. So angle C would have to be congruent to angle D. And all of this information is also marked in our diagram. We can clearly see angle A and angle F have the one arc congruence mark. Angle B and angle E have 2 arcs, and C and D have the 3 arcs. So those are our 3 pairs of congruent angles. Now the sides work in the same way. If you take the first 2 positions, we have A and B and F and E. Those form a side. So those 2 sides would have to be congruent based on our congruent statement. Okay, so we can see that down here. AB is congruent to FE. Now B and C and E and D are in the second and third positions, so they are also a congruent pair of sides, as well as AC and FD, which are in the first and third positions of both of those names. So a congruent statement is very important because not only is it telling you the triangles are congruent to each other, but it's telling you which parts of the triangle are congruent to each other. All right, so moving on. Now what we're going to do is try an example and identify all of the corresponding parts. So pause the video at this point and take a minute to see if you can identify all 6 corresponding parts of these 2 triangles. Welcome back. Were you able to find all of the 6 corresponding parts? Let's see. Let's start with the angles. So if we look at the diagram, I can see that angle K and angle S are both marked with 1 arc. So I know that angle K is congruent to angle S. I'm going to find a second pair of angles. So I see down here, angle L has 2 arcs, as does angle R over on the right. So angle L is congruent to angle R. Finally, angle J has 3 arcs, as does angle T in the second triangle. So angle J is congruent to angle T. Okay, now let's move on to the sides. So the first side I see marked with one congruence mark is side JK. In the other triangle, the same congruence mark shows up on side ST, so those would have to be congruent. Now let's go to 2. LK has the 2 congruent marks, so that side would be congruent to SR, which has the same number of congruent marks in the second triangle. For our last pair, we have JL with the 3 tick marks, which is congruent to RT in the other triangle, which also has those 3 tick marks. So now we've identified all of our 6 corresponding parts in these 2 triangles. Well, what we can do at this point is we can actually write our triangle congruent statement. So when I want to pair these up, I'm going to start with one of the 2 triangles. Let's start with the one on the left. So I know that that is triangle JKL. Now the order of the letters doesn't matter for the first one. What's important is how you write the order for the second triangle. So when I go to write my congruence statement, for the second triangle, I'm going to figure out which vertex matches with vertex J. Well, J is over here, which had the 3 congruent marks. So that vertex matches up with vertex T in the other triangle. So I have to start my name with T. Now K, right here, is the one that had the 1 arc marked on it, and that matches up with vertex S. So S is going to be my second letter, which leaves R, which matches up with L, both with the 2 congruent marks. So a correct congruent statement for these 2 triangles is that triangle JKL is congruent to triangle TSR. All right. Now let's take a look at another example without triangles. In the diagram, we see the information at the top, which says that ABCD is congruent to FGHK. That congruent statement is going to provide me a lot of important information. Now I know which sides and which angles are going to be congruent in my 2 figures. And that's going to help me find X and Y. So first let's take a look at X. I can see that 3x minus 6 inches is the length of side FG. So I'm going to go up to my congruent statement, and I see that FG is in the first 2 positions of my congruent statement. When I look at the other side, AB is also in the first 2 positions. So now I'm going to go down to the ABCD figure, find side AB, and I know that this side is congruent to FG in my other triangle. Since they're congruent, I can set them equal. So my equation would read 3x minus 6 equals 9. Now we can solve for x. So I'm going to add 6 to both sides. So 3x equals 15. And then I can divide by 3 to get x equals 5. Very good. Now let's take a look at y. So y is over here on the right side on angle J. Now I need to figure out which angle matches with angle J. Oh, it appears we actually have an error in the congruent statement up at the top. This should say FGHJ, not K, because J is the 4th letter. Okay, so sorry about the confusion, but J is going to be in the 4th position of our congruent statement. So I know that angle J is going to have to be congruent to angle D in my other figure. Okay, so I'm going to go and mark angle D, because those are the 2 angles that I'm going to compare. So now that I have this information, I know I can set them equal to each other. So 5 plus 2y, which is angle J, equals 75 degrees from angle D. So now I can solve for y. Subtract 5 from both sides. So 2y equals 70. And then divide by 2. So y equals 35. So using my congruent statement, I was able to find that x equals 5 and y equals 35 in the diagram. Now notice that there was some information we didn't end up using from the diagram on the left. Line BC was labeled as 11 inches. Side AB was labeled as 15 inches. And then we had angle A 80 degrees and angle C 105. So sometimes there will be extra information in your diagrams that you don't need. Make sure you match up your information to the correct congruent part in the other triangle. Next up we have a theorem, theorem 4.3, called the third angle theorem. Take a minute to copy this into your notes. So again, please pause the video so that you have time to copy this down. Okay, so let's read through this theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So if we look at the diagram, we can see that angle B and angle E are marked congruent to each other. We can also see that angle D and A are marked congruent. So we already know that those two pairs are congruent in both triangles. So let's think back to what we know about triangles from the last lesson. We know that we know that the three angles in the triangle are going to add up to 180 degrees. So let's make up some degree measures for a second to help us understand this theorem. Let's say angle B equals 80 degrees. That would mean angle E was also 80 degrees. Okay, now let's say angle A is 40 degrees. That would also make angle D 40 degrees since they're congruent. So in total, what we have so far in triangle ABC is 120 degrees, and the same for triangle DEF. Well, knowing that I'm going to need 180 degrees total, if I subtract 120 from 180, I'm left with 60 degrees. So angle C would have to be 60 degrees. Okay, the same is true for angle F because both of those need to add up to 180. Therefore, we know that angle C and angle F have to be congruent. Okay, moving on. Oh, seems like we got a little stuck. There we go. Okay, back one. All right, let's take a look at this example here. So we have the measure of angle BDC that we're trying to find in this diagram. Now, there's some information marked here. We have angle A and angle B marked congruent. We also have angle NCD and NDC, both with two congruent arcs, or marked congruent with the two arcs down on the bottom. Now, I'm going to show you the hint for this one because we have the 45 and the 30. So there is a couple ways to actually find angle BDC, but there's one way that we can use the third angle theorem. So let's take a look. Excuse me. Our hint is that we're going to draw the triangles separately. Now, what do I mean by the triangles? Well, I'm going to show you two overlapping triangles that are going to be very helpful for solving this problem. The first one, triangle ACD. Okay, now if I mark that with all of its information, the 45 and 30 degree angles, what I can do is take this and actually move it over to the side. Okay, so what I did was I recopied it. It's a triangle that's overlapping another one. But I can clearly see when I remove it over to the left that I have a 45 degree angle, a 30 degree angle, and then one angle that we don't know yet. All right, let's do the same thing for triangle BDC, which contains our angle. So let me outline it first, get our two angles in there, and our three vertices, and let's move this one over. Okay, now compare the two triangles on the left and the right. Notice that they have two pairs of congruent angles. So even though the degree measures aren't marked in triangle BDC, I know that they would be 30 degrees and 45 degrees, just like they are in the triangle on the left. So by the third angle theorem, I know that angle ACD and angle BDC have to be congruent. The last thing I have to do is figure out what the degree measure is. So I know that they add up to 180. So I'm going to take 180 degrees. Then I'm going to subtract the amount of degrees that I already have for the other two angles. Well, 30 plus 45 is 75. So I need to subtract 75 degrees to find out how many are left for my two third angles. 105 degrees is what's left. So that is the degree measure for angle ACD and also angle VDC, which is the one we were looking for. So that's the answer to our question, 105 degrees. All right, now it's time to take a look at a proof. So notice our given information. We have a bunch of different sides marked congruent and a bunch of different angles, or excuse me, one pair of angles that are congruent. But none of that is actually marked in our diagram. So the first thing that I'm going to do is mark all of this information into my diagram so I can see what I have. All right, let's start with the first given. SB is congruent to RV. I'm going to mark that. Second thing I see, TV is congruent to WV. Okay. Third thing, ST is congruent to WR. And finally, angle T is congruent to angle W. So what I have in my two triangles are all three pairs of congruent sides and one pair of congruent angles. So what I need are the last two pairs of congruent angles in order to prove that these two triangles have all of their corresponding parts congruent. So if we look at statement 2, it says angle SVT is congruent to angle WVR. So if you look in the diagram, try to decide what reason would prove these two are congruent. Did you come up with the vertical angle congruence theorem? If we mark them, we can see that those two angles are vertical angles. So one of our reasons can be they're congruent because all vertical angles are congruent. All right, statement number 3. Angle F and angle R, the last pair of angles we have in both triangles. So what reason can we use to prove that those are congruent? Did you say the third angle theorem? Remember, we already have two pairs of angles. We had angle T congruent to angle W from our given information, and then we just proved that angle SVT and WVR are congruent by the vertical angle congruence theorem. So we can therefore conclude that angle S is congruent to angle R because it's the third pair of angles in both triangles. So we're using the third angle theorem. All right, now on to statement number 4. This one says triangle STB is congruent to triangle RWV. Now we can prove this for the reason that we got at the beginning of the lesson. When all the corresponding parts of the two triangles are congruent, then the triangles are congruent. And I just use the congruent symbol there at the end to fit it in. So now that we've seen a proof using this, let's take a look at the next slide. Using the diagram, we want to think about if there's a way to show that the two triangles pictured in this diagram would be congruent. And if they can be proven, what would be the correct congruent statement to state afterwards? All right, so what I see in the diagram are three pairs of sides marked congruent. So I'm going to write those below. I know that PS is congruent to QR. I also know PT is congruent to TR. And finally, ST is congruent to TQ. Okay, so 3 pairs of sides is good, but it's definitely not enough because I need to have 3 pairs of angles as well. So I'm going to start with angle PTS and angle QTR. I can see that those are vertical angles again, so I know that those are going to be congruent. Okay, now I need to find a way to prove the other pairs of angles are congruent. And the one thing that I haven't used in the diagram yet are the arrows on PS and QR. So the arrows are telling me that those two lines are parallel. Now remember, when we have parallel lines, we also have a transversal, which gives us angle pairs. So if I look at line PR, okay, and imagine it goes through, then I know I have a pair of alternate interior angles that are congruent. So that means angle P is congruent to angle R. Okay, let's get rid of that line so that we don't have to see it anymore, because we want to look at our other transversal. So the other transversal is line SQ, which again produces a pair of congruent alternate interior angles. I'm going to mark this one with 3. Okay, so angle S is congruent to angle Q. I'm going to get rid of that one more time. Let me get my other congruent symbols back in the diagram. So now I can clearly see I have 3 pairs of sides and 3 pairs of angles, which is enough to prove that these two triangles are definitely congruent. To write my final congruent statement, I'm going to start with the triangle on the left. So triangle PTS is congruent to. All right, so now here's where I have to come up with the order of the letters in the triangle on the right. Well, since I started with P, which has the 2 arc marks on it, I'm going to find the same one on the right, which is R. Then I went to T in the one on the left. Now T is the same one in the one on the right, so T should be next, which leaves our final vertex, Q. So the correct congruent statement is triangle PTS is congruent to triangle RTQ. Okay, this is the last bit of theorems that we have for this section. It's the 3 properties that we've seen before: reflexive, symmetric, and transitive. Please pause the video here and take a minute to copy these into your notes. I'm not going to go through these properties right now, but if you have questions, ask your teacher during the next class. This is the end of lesson 4.2.